Hey, hey! Listen, man. My name is Mntwana. I'm original African, original black man. I'm a caveman. Let's get started. So we have a some question right here. Okay, let me see my camera record right. Okay, I see. Thing like this can be way better. Sorry about that. So we have a couple of questions here. So let's get started. I can start with either one. Let me start with the last one so that I can go up, I can have a space. Or I can start at this side, and then when I finish, I'll go to the other side. Okay, I want to make sure if I have all my tools. Yes, I do have all my tools. Let's start with the last one. So the last one is easy because this is a tricky double angle. How do I know? Look, when you're in double angle tricky, if somebody give you cos, double your angle, let's say theta or x. This equal to, since I want to change to x's, I think it's very important for me to explain to you so you know how these things comes about, right? Look, in cos double angle, so let me say cos double square of angle minus sine square of angle. But here we just need cos square of angle. Cos square of, so it means I don't need this. I don't need this. Means this, let me say, if I replace sine as 1 minus cos square, so it's going to be 2 cos square theta minus 1. You see what I'm saying? So now what happened now? I say, okay, well, this is, let me say, cos double my angle. But now with 3x, you see, which one look like this, look like that. So this, let me say, 2 cos, but here I'm going to say square 3x minus 1. If this 3x, this must be, means the angle 3x means this is going to be 3x times equal 6x cos 6x equal to that. But my intention, I want to come and replace that. I want to come and replace this one, means this one is going to come over. So let me say cos 6x plus 1 over 2 equal to cos square of my angle. So now I'm going to take this and replace over there. So this, let me say, integral. Okay, 1 over 2 is going to go to the back. 1 over 2 is going to go to the back, and this will be cos, okay, 6x plus 1 over, no, the 2 went back, so I don't have to write over again. Let me put here, so this is 4, and like I say, dx. Do you understand what I'm saying? So, well, so I can finish up. I just want long route so that I can make you understand for the new one or for the people who don't understand. Because all my intention is to make also why I'm going fast, also you have to understand. So then what happens is going to be 1 over 2 is at the back, and then this, or we can say equal to, okay, so it's going to be, when you, okay, look, if somebody give you integral cos of a function, dx, this time I say 1 over, derivate your function, means I'm going to say f prime, and then when you derivate cos, you get sine. When you integrate cos, you get sine of f of x. So for that case, now I'm going to say, okay, now I have to derivate this. If I derivate that, it's going to give me 1 over 6. And this is going to be sine of a function. Our function is 6x plus 1 and the plus c. Why we plus c? Because there is no limit. 1 times 1 equal to 1, 2 times 2 equal to 2, 2 times 6 equal to 12, and then it's going to be sine and 6x plus 1, and then we plus c. So we're done with this question. Now we go to the question number 1. Go to question number 1 quick. Okay. Let's go, man. This question here, surprise. It was saying surprise to me. You know, you can see how I wrote there. It's a surprise. Someone sent to me someone very in a high position. Now let's go. So we have question number 1. Question number 1 is actually way easy, but I want to show you the concept quick, right? So I want to take this and reciprocate to the top because I can say 1 over cos square. So this, let me say integral 1 over cos square go to sec square, and then I have a 3x, and then here I have a tan square 3x minus 5, and then dx. Look, these are rules, okay? So the more you do, the more you get used to them. So get used to the rules, okay? Now, so for this one here, whenever you have a question in this form, like, look, if you differentiate this, tan x is going to give you sec squared. Like when you, okay, when you differentiate the functions, like say, look, if you say tan square x, like tan, like this. So when you derivate this, it's going to give you sec squared. So when you have that situation where you have a function, when you derivate everything in a function, it gives you something outside. Then you apply this rule only if in that condition. So the rules say, if you have a let's say integral, and then this is f of x square plus or minus a square. Well, you know, when you derivate this, it's going to give you f prime. See what I'm saying? Like that. Time to get that one. And then dx. This, let me say, or sometimes you can use u, whatever you want. If you don't want to use fx, you can use u. So this, let me say, 1 over 2 fx, and then you can say square root. You write exactly f of x square minus a square. You see what I'm saying? And then what you do, it's minus here, right? If it's minus here, you're going to write minus. So say here minus. And then take your a square. And then over to, what is the a square? A is this, whatever you're seeing here. And they say ln. And then write exactly. Okay, f of x minus a square. And then you stop there. And then you plus. You see what I'm saying? And then what you do, you plus your f of x. Oh, let's use another color here, so you don't want to mix up and sound and seems like, okay, and then f of x. But remember, there's a ln here, so since there's a ln, this shows me you can write your bracket, say, okay, after the ln, and then I can put my bracket, say like this. And then you plus your c. So what I want to do here, I have all the values. Let's come and plug in here. So I say, well, this equal, what is f of x? F of x is this one here, tan of 3x, tan 3x over 2. 2. Oh, this pen is finished. Let's get another pen. Over 2 over 2. And then what we do is say, well, multiply, and then is it. Okay. This is same as that. So say tan 3x square, or you can put square here, minus. We say, what? A square. What is a square? A square means this number here. Okay. So we got a problem here, right? So this number is not in square. So we have to make it square. So how are we going to make it square? It's 5, right? So to make it square, if somebody say 3, how are we going to make square? You can say 3 square root and then square, because it gives the same value. So the reason I'm doing this, so it can look like it has a square. So for that case now, it's going to be the number which is a is going to be square root of 5. You see what I'm saying? And then we should say minus. A, what is a? Our a equals square root of 5. And then we over square root of 5 square, which is same as 5. So I don't have to say square root of 5 square, because this square cancel. So I can say equal to 5. And then over 2 ln. Okay, and then we say absolute. So we need a space here, so it means I have to erase that one to have some space. Okay. Okay, now we come here, f of x, square root, f of x, what is f of x? Tan 3x, what? Square, and then we say what? Minus, a square. A square means this and this one is going to give 5. You close, and then we plus f of x, what is f of x? Tan with no square, tan of 3x with no square, and then you plus c. But, okay, when you do that, in the formula it does not show, but here you must divide. You divide by what? Look at this number, 3x divided by that number which is in here, 3. Do not forget that. In the formula it does not show, but when you do your calculation, make sure you write that number. If it's 5 and 5, you write 5 here. But for this case, 3, you write 3. So what we do, look, common denominator is 2. So it means everything divided by 1, 2. You see what I'm saying? I don't have to write over 2 and then this group over 2. Means I can say all of this is under base 2. But this is going to come here. It's going to be 2 times 2 equal to 2 times 3 equals 6. So I can say simply 6. But when you calculate it, show step by step. So this is going to be equal to 6. So now that question is done. Now we go to question number 2. So let's just erase here so I can have a space. Let me show that it's record. Sometimes it does not record. Yes, it does record. Okay, it does record. Okay, cool. Okay. So we go to question number 2. Number 2 is almost similar, right? Let me start with, let's go number 2. Number 2 is almost similar to the one we just did now. So I want to say, well, number 2. So I want to say this, let me say integral. So this is going to be tan 3, 4x plus 49 means 7 squared. And then we over. So I don't have to write this no more. I can say this, let me say cos sec, because 1 over cos square equals to sec square 3x dx, but we have a root here. So we're going to use the same tactics, because if I differentiate tan of x, this let me say tan for x or square plus 49 bracket, there's 2 bracket here. Bracket, and then another bracket. So you see, when you differentiate tan for x, this must be false, sorry, this must be false. Means when I differentiate, this must be false, sorry. Means when I differentiate, this is going to give me sec squared. So I'm going to apply the same tactics. We say, okay, if somebody gives us an integral, let me just, oh my God. if somebody give us an integral, 1 over, I don't know, somebody give you u square, and they give integral of u square minus plus 7, yeah, plus 7. Okay, plus 7. This same as du equal to, we're going to say u over 2, and then we say u over 2, then we say square root to write exactly u square plus a square. Here we say a, not 7. A, because the formula is just formula, right? So then we say this is going to be minus minus, and then we say a square over 2, and then we say write exactly, and they say long, and they write what? Exactly. Okay, what is exactly? Means this one here. We say okay, u square plus a square plus, oh no, I made a mistake. If this plus, this must be plus also. Okay, and then here everything stay the same. So plus plus, and then we say here is going to be plus again, just like how we did, which is going to be only u, and then you close your absolute plus constant c. You understand what I'm saying? So now let's go and plug it in there. So you can use fx or u. So then we can say, well, okay, just a minute, let me get my pen. So we say, well, okay, so this could be integral. Oh no, we don't have to write integral again because it means this is there. So you can say some equal, means equal u over 2. What is that u? U tan of 4x, tan 4x, okay, over 2, over 2. Okay, over 2, and then we say we multiply, square root, multiply, square root, you can do this, okay, square root, okay, u square, what is u square, tan, I don't think space can be enough here, let me start from the right at the beginning, so the space can be enough, because I don't want to write and the space not going to be enough now. Okay, so we're going to say equal, u, what is a u? Use tan 4x, and then over 2, and then we say multiply with that u, what is a u? Tan 4x, okay, plus a square, what is a square? Means 7 square, which is 49. Okay, plus, what do we plus now? Because it's plus, but if it's minus, you must write minus here. But if now it's plus, and they say a square, what is a square? Means 7 square, which is 49. We have some fun here, over 2, ln, and they say, okay, absolute, u square, what is a u square? Tan, my pen. Okay, so we say tan square, but we got root here, right? Don't forget root. Tan square plus tan square what? 4x plus a square. What is a square? A square 7 square 49. Okay. So let me write this question here. So then I'm gonna come in at 10 then. Okay, so let's write the question here. So this is 1 x squared plus 5x plus 40. Okay, that's the face on, which is question number 4. Question number 5, so that I can have space there. 1 over t squared plus 4 t plus 5 dt. You see what I'm saying? Excuse me, sorry. So now I can simply raise this one to have some space, since I already have a question on the side. Okay, I already have a question on the side. Well, so okay, plus 49, and then we plus u. What is a u? Tan 4x. What is the tan of 4x? Tan 4x. So this absolute must close, open and close absolute. Close, and then we plus our c because there's no limit. But remember, hey, we must divide by this number here, 4x, 4, whatever 4x. We divide only by 4. You know what I'm saying, by 4. So what you do now, remember this is divided by 2, means I can multiply this, going to be 8, multiply this 8. So together it's going to be tan 4x, tan 4x plus 49 plus 49 ln absolute tan square 4x plus 49. All of this in one bracket, and then we plus tan 4x, and then we plus c. So this is going to be 8 and 8, means together in a single bracket equal to 8, because multiply is going to be 8 multiplied by 4 together, or 2, and then you multiply, because 2 is going to be 1, 2, and then multiply 4 equal to 8. So, oh yes, we're done with that. So now let's go to the next question. So the next question is actually way easy. You understand what I'm saying? It's way easy. Oh my God, I love this. It's very interesting. Excuse me, just forgot something quick, just a minute, sorry. Yeah, I got it, sorry. Something was smiling, I thought it'd be something's bending, you know, so sometimes I want to make sure I check it. Okay, now, the next question is way actually easy. So let's say here, they give us integral, and then 1 over x squared plus 5x plus 10 plus 40. So, when you have this type of question, on top there's a 1, at the bottom there's that. The first thing you could have done is to do partial fraction and see, okay, can partial fraction work? But for you to do partial fraction means you must factorize. But you try to factorize. If it's not working in that, then you have to think of trig inverse. Let me say it again. It's very, very important because that's why a lot of students get confused. You understand what I'm saying? Because sometimes they don't know what to do. So if we try to factorize this, look, you want to check the root of quadratic. So the root quadratic is always say b squared minus 4 AC, this pen is finished. B squared minus 4AC. If it's greater than 0, then you know the roots are real. Let's see, it's true. B squared means 5, square equal to 25, minus 4 times A equal to 1 times C equal to 40. So if you can look careful, this is going to be less than 0. Because 25 minus 160, 25 minus 160, so we know this is going to be less than, 0. So the root of quadratic is going to be imaginary. And if the root is going to be imaginary, by any means you cannot factorize. Means there's no real root of quadratic. So for that case, you cannot use partial fraction. So meaning we have to do another method, which we can do by doing completing the square. That's why a lot of students get confused. Like, okay, should I just factorize or should I do complete the square straight away? You gotta test to check the root of quadratic, the root of this quadratic. So we have checked, which is imaginary roots. So means we cannot do like that. You see, we cannot do partial fraction. Means we're gonna do normal completing the square. How are we gonna do the loop? So completing the square means this is gonna be x squared plus 5. Okay, let's do here. X squared plus 5x plus 40. So this is going to be x squared plus 5x divided by 2 divided by 2 plus going to be 5 divided by 2 equal to 5 divided by 2. Square is going to be 25 over 4. Same thing we're going to do here. 40 minus 25 because here we plus 25 over 4. Okay, the next thing here, this is going to be x plus 5 over 2 bracket square. And then here's going to be plus 40 minus 25 over 4. 40 minus 25 over 4, what's my calculator here? She's really just trying to do like grade 1 now. Okay. 40 minus 25 over 4, common number here is going to be 160. 160 minus this is going to be 25 and then divided by 4. Okay. 135 over 4. Okay, so this is going to be 135 over 4. 135 over 4. So, for that case, we say, well, 135 over 4. So here I'm going to say 5 over 2. So we're putting it root quadratic. So 5 over 2. And then plus 135 over 4, and you have a 1 over dx. So this you can use a tan substitution, because we know for tan, if somebody give you 1 and they give you a squared plus f of x squared, this is a tan because we're going to say 1 over a, and then you say arctan or tan inverse. When you say arctan and tan inverse, the same thing. You write f of x here, and then over your a plus c. But only when there's no root and it must be plus there. Only if there's no root and it must be plus there. Oh yes, the same thing. There's a plus and there is no root. So we can use the same tactics. You know what I'm saying? So which tactic is that? Well, I'm going to say, but first and foremost, I need to put this as a square number. It's because this is a. So to put this as square number, I can say 135 because I don't have this. So say this is the same as a square, and this is going to be 2 square. So I can say all of this do like this. Square means this is going to be 135, this is going to be 4. So I can simply change this to a square number, which is going to be square root of 135, and this is going to be 2 square. So I can say over 2 and then 1 square. So now we can apply our tan inverse. How are we going to do our tan inverse? Look how easy it becomes. So for tan inverse here, look how interesting it became. So this is going to be equal to 1 over a. A is that number right here. This is going to be 135 over 2. So this 2 can go to the back, to the top. So I can say 2 to the top. Okay, and then arctan, okay, say tan inverse or arctan is the same thing. Arctan or tan inverse is the same word. Okay, And then we write this one because it's f of x. What is f of x? This one O. Which is no square. I'm sorry. Which is going to be x plus 5 over 2 over a. Because they say over a. A, we write our a. 1 over a. What is a? A, that one, but a 2 went to the top. Oh, you know what I'm saying? And now this will be x plus whatever divided by a. A is this number here with no square. So square root of 135, 2 is going to go to the top. So we're going to say 2. And then what we say? O plus C. C, our C, just say C. And that's the end of the first question. You understand what I'm saying? Now we go for the last question. The last question is actual. We say the last, so means interesting, and I must do very quick. Okay. Very interesting. I love it. I love it. Okay, let's go last question here, quick. Last question. Okay, the last question. Oh my God, this is way easy actually. Okay, so 1 squared plus 4t plus 4t plus 5 plus 5 dt. Okay, let me use the green color. Let me use the green color for so long. So what we're gonna do? We're gonna can you find the root of quadratic? Let's see. So we're gonna say b squared minus 4ac. If it's greater than 0, yes, we can find the root of quadratic. What is b? b for 4 squared equal to 16 minus 4 times a equal to 1 times c equal to 5. So it's not a real root because this will be 16. 16 minus 20 equal to negative 4. Negative 4 is less than 0. So if it's less than 0, means your roots are not real root. But if you get the number here which is greater than 0, then yes, you can factorize. And then you can use factorization. And then you can use partial fraction. And then after partial fraction, you can use ln, which is way easy. You see what I'm saying? I'm going to show you some of the example for that case soon in the next example. So you should follow my video. So for that case here, you cannot factorize because the root of quadratic is less than 0. So what we're going to do, we're going to do completing the square. If it's not, means completing the square. If it is, then you can use partial fraction, and then we use a ln. Okay, so then this is going to be integral, and this is going to be 1. Okay, t squared plus 4t plus 5. So t squared, okay, so t squared plus 4t plus 5. So we say factorize, completing the square plus 4. T plus, okay, 4 divided by 2 square equal to 4. And this is going to be plus 5 minus the same thing, which you plus you minus. So it's not going to make any difference. So this is going to be t plus 2 square equal to that. And this equal to 1. 5 minus 1 equal to, okay. So now we're going to say 1 over t plus 2 plus 1. And then you say dt. So what we're going to do here, this is turn substitution. And then we're going to say 1 over a. What is a? A is this number. But you can put square because 1 is square equal to 1. So 1 over this number with no square, and then we say add tan. If you don't want to say add tan, you can say tan inverse. Either way, write whatever you have here, which is going to be t plus 2. You divide by this number. For this case is 1, and then we plus our constant. See, listen, I'm an original black man. I'm a caveman. Leave the comments below. Share this video, right? And you tell me what type of video you want me to make, okay? For that being said, follow me on my Instagram, Mntwana _Wabantu. This was a very special question. 99.9% of a lot of students, they get confused. It was one of the tests where a lot of students, they go wrong, most of them, because they confuse a lot of concepts. Okay, thanks a lot for that being said. I'ma see you soon. Follow my page, Mntwana _Wabantu. Leave a comments below. Tell me what you think, what type of video you want me to make. Peace and love. I'll see you soon. Peace. I'm out.